Hello there, Mr. Sutton here, bringing you the BC Calculus 516 Extra Practice Number 3 solutions on integration by partial fractions. For this problem, we're trying to find the indefinite integral of this one. So I see here that the denominator looks factorable. It's actually going to be x plus 3, x minus 3. So we could try integrating this with partial fraction decomposition. I mean, there's nothing else we can do here. So let's give it a shot. So I've got 1 over that. I'm going to set this equal now. I'm going to basically split this up. There is some a and b value such that I can break this up into a over x plus 3 plus b over x minus 3. And then if I multiply everything here by x plus 3, x minus 3, on the left side, everything cancels out and I just have 1. On the right side, the x plus 3's cancel, leaving me with a times x minus 3. And now the x minus 3 cancels, leaving me with b times x plus 3. All right, at this point, I'm going to pick some convenient values to plug in to solve for a and b. So let's say that I want to solve for a first. So let's let x equal negative 3 to start with. So that's going to cancel out this b term here because I'm going to have basically 0 times b. I'm going to have a 1 equals, and let's see here, this is going to be negative 6 times a. So then a is going to be negative 1 over 6. Now I'm going to do the same thing to find the b value. This time I'm going to plug in 3 for x. That's going to get rid of the a term. So if x equals 3, I can write 1 equals, and this is going to be 6 times b. So that means b is really going to be 1 over 6. Rewriting my integral now, using the a and the b that I just found, I can write, let's see here, negative 1 over 6 over x plus 3 plus, now I can write 1 over 6 instead of b over x minus 3 dx. And then for each of these, I'm just going to use my ln antiderivative. So this first one, this is going to be negative 1 over 6 ln absolute value of x plus 3 plus 1 over 6 ln absolute value x minus 3. Don't forget the plus c. On this problem, I'm trying to take the antiderivative of 1 over 1 minus x squared. Now, there's nothing I can really do to simplify this or use any of my other antiderivatives. So what I'm going to do here, since I notice this denominator appears to be factorable into distinct factors, I'm going to give that a shot and see if I can use partial fraction decomposition on this. So let me split this up into 1 plus x and 1 minus x. And then I'm going to set this equal. I'm going to basically write a fraction for each of these factors in the denominator. So I'm going to split this up into a over 1 plus x plus b over 1 minus x. And there's some magic a and b value that makes this true, which I will now proceed to find. So I'll do that by multiplying everything by 1 plus x and 1 minus x. That gives me just 1 on the left as that whole denominator cancels out. On the right side, for this first fraction, the 1 plus x's cancel, leaving me with a times the remaining factor of 1 minus x. And then for this b fraction here, the 1 minus x's from this denominator are going to cancel, leaving me with just b times 1 plus x. At this point, I'm going to pick an x value that cancels out first b and then a, so I can solve for a and b. To get rid of b, I need x to equal negative 1. That will make this 0 here. So if x equals negative 1, b is going to be gone. And I can write 1 equals, and this is going to be 1 minus negative 1, so 2 then, 2a. 1 equals 2a. So that means a must be 1 over 2 to make this whole thing work. Now to get rid of a and solve for b, I need x to equal positive 1. That being the case, I can write 1 equals, and this is going to be b times 2, so 2b. Or not 2b, that is the question. Now I'm not going to go into a soliloquy here, but b is going to equal 1/2. So now going back to the original and splitting this up, I can rewrite my integrand as, let's see here, we have the a value 1/2 over 1 plus x. And then we have the b value, which is also 1/2 over 1 minus x. Don't forget the dx. Now for each of these, I can just use my ln absolute value antiderivative. So this first one antiderivative is going to be 1/2 ln absolute value of 1 plus x. And then for this next one, now we got to be careful here because I've got a 1/2 ln absolute value of 1 minus x, but the derivative of the inner function here is negative 1. I have to divide by that since it's not just 1. So this ends up being minus 1/2 ln absolute value of 1 minus x. And then we have our plus c. For this problem, trying to find the antiderivative, I can't really simplify this, but I do notice that the denominator is factorable, so I might try integration by partial fractions on this one. So if I factor that denominator, that's going to be x plus 3, x minus 3. And then I'm going to try to split this up and set this equal to, I'm going to have a over x plus 3 plus b over x minus 3. And there's some magic a and b value that somehow makes all of this true, hopefully. To figure out what it is, I'm going to multiply both sides of this equation by x plus 3, x minus 3. That cancels out the whole denominator on the left side, giving me just 3x minus 2. On the right side, this first fraction, x plus 3's are canceling, leaving me with a times x minus 3. For this next fraction, the x minus 3's cancel, leaving me with b times that remaining factor of x plus 3. And at this point, I'm going to solve for a and b. Basically, I'm going to plug in an x value that gets rid of one or the other, and then I can solve for whatever's left over. So if I want to solve for a, to get rid of b, I need to plug in an x value of negative 3. If x equals negative 3, then on the left side of the equation here, this is going to be negative 9 minus 2, so negative 11. And on the right side, again, b is just going to get zeroed out, so that's gone. But a, we have a times, and this is going to be negative 3 minus 3, so negative 6a. Solving for a really quickly here, we have a equals 11 over 6. Now moving on, I'm going to solve for b. That means I have to get rid of the a term. To get rid of a, I need for x to equal 3. If x equals 3, on the left side here, this now becomes 9 minus 2, which is 7. And on the right side, again, a gets zeroed out. b, we have b times 3 plus 3, which is 6b. And that means b must be 7 over 6. All right, so I found a and b. Now I'm going to split up this integrand here using this a plus b kind of fraction setup. So I have the a value 11 over 6 over x plus 3. That's half of my integrand there. And now I've got this b value of 7 over 6 over x minus 3. That's the other part of the integrand. Now I can use my ln antiderivative for these. So I have 11 over 6 ln absolute value of x plus 3 plus 7 over 6 ln absolute value of x minus 3 plus c. On this problem, I noticed that I can't really simplify this to take the antiderivative, at least not easily, but then there's simplifying it less easily. I noticed that the denominator at the very least is factorable, and the factors are going to be different, so this is a good candidate for partial fraction decomposition. So let me start by actually factoring this. So two things that multiply to negative 15 and add up to negative 2. I can split this up into x plus 3, x minus 5. And then I'm going to split this fraction up further. I'm going to set this equal to a over x plus 3 plus b over x minus 5. So each factor gets its own fraction, and I'm going to try and break this down and find an a and b value that actually makes this equation true. To do that, I'm going to multiply both sides by x plus 3 and x minus 5. That gets rid of the whole denominator on the left side, leaving me with just the numerator of x. On the right side, the first fraction, x plus 3's are going away, leaving me with just a times x minus 5. And for this next fraction, the x minus 5's get canceled, leaving me with b times x plus 3. To solve for a and b, I just have to pick x values that get rid of one or the other of them. So for example, to solve for a, I need to get rid of this b term. I can do that if I just plug in the x value negative 3, because negative 3 plus 3 would zero out this whole term. So let's say that I do that. If x equals negative 3, then I can write this equation as negative 3, because that's what x is, and we're plugging it in for x, equals, and now we're going to have a times negative 3 minus 5, so that's negative 8a, and then again b is canceled out, zeroed out. So given this equation, a must equal 3 over 8, so there's my a value. Now to get the b value really quickly, I'm just going to plug in something that gets rid of this a term, like x equals positive 5. So I've got then 5, because again I'm plugging that in for x, which happens to be the left side of the equation. So 5 equals, and now this is 0a, so that's gone. Over here we have 8b, so that means b is going to be 5/8. All right, so we're going to split up this integrand using this little a plus b fraction setup here. So now that I found a, I can write 3/8 over x plus 3, and I'm rewriting the integrand now. And instead of b over all this, I can write now 5/8 over x minus 5. And now I'll just take the antiderivative of each of these. So for this first fraction, this is just 3/8 times the ln of the absolute value of x plus 3. And for this next term, I have 5/8 ln absolute value of x minus 5, and we're adding that term. And then finally, plus c. For this problem, this looks like a bit of a mess here. Substitution doesn't look like it's really going to work on this one. So maybe if I try factoring and simplifying, I mean, who knows? Let's try the numerator first. I can split this up into 3x and x in my parentheses. And then, let's see, I need one of my parentheses to have a positive 1 and one to have a negative 1. Let me just try splitting it up like this. So 3x plus 1, x minus 1. Let's see if this works out. 3x times negative 1, that's going to be negative 3x. We have a positive 1x in here, and that adds up to negative 2. Hey, lucky me, I got it on the first try. All right, now for the denominator, try factoring this. I can take an x out of both of those. That would leave me with 9x squared minus 1. And then those are both perfect squares, so I can split that up into 3x plus 1 and 3x minus 1. So at the very least, I can cancel out these 3x plus 1s. So this is a good thing. So I end up with x minus 1 over x parentheses 3x minus 1. So this is looking a little bit nicer. But there isn't really anywhere I can go from here. I can't simplify it anymore. There's no other techniques I have that are really going to cancel everything out and get me to where I need to go. So I'm going to try partial fraction decomposition here, because at the very least my denominator is factored into unique factors. So let me split up this fraction in an equation here. So I'm going to write that this equals a over x, my first factor, plus b over 3x minus 1. And now to solve for a and b, which I need to do to make this work, I'm going to multiply both sides by x times 3x minus 1. That cancels out my denominator on the left side, leaving me with just x minus 1. On the right side, the x's are going to cancel, leaving me with an a and a 3x minus 1. And for this next fraction, the 3x minus 1's cancel, so that's just going to be b times x. At this point, I need to solve for a and b by plugging in a convenient x value to get rid of one or the other of them. I'm going to solve for a first. To do that, I need to plug in the x value 0, because that would get rid of this b term. So if I plug in 0 for x, on the left side of this equation, 0 minus 1 is just negative 1. I've got, let's see, a times 3 times 0 minus 1, so this is just negative a right here. And then b gets zeroed out completely. So then I can just write that a equals 1, which is a nice value for a to equal. Now I need to find the value of b. Well, I'm going to plug in something that gets rid of the a term. So what would zero out 3x minus 1? Well, if I set this equal to 0 and added 1 and divided by 3, I see that 1/3 is the magic x value that gets rid of the a term. So on the left side, we have 1/3 minus 1, which is negative 2/3. A gets zeroed out by this. And then we have b, or plus, this is going to be b times 1/3, so 1/3 b. All right, well, I have to solve for b here. So if I divide negative 2/3 by 1/3, that's going to just give me negative 2. You could also think of just multiplying both sides by 3. b is going to be negative 2. Now I can split up this integrand here into what we have here. So I'm going to have my a value of 1 over x, and then I'm going to have my b value of negative 2 over 3x minus 1. So I'm going to do minus 2 over that stuff. Now using my ln antiderivative, I can write this first term antiderivative as ln of absolute value of x. This next one I have to be a little bit careful. I have a 2 out in front initially. I'm going to have an ln of absolute value of 3x minus 1, but because this is a linear inner function here that doesn't have a derivative of 1, I have to divide by that derivative of 3. So I eventually end up with negative 2/3 ln absolute value of 3x minus 1. And don't forget that plus c.